Hi guys, so we have an O-level past paper question from the year 2018. The session is October-November. This is question number 10, the last question of this paper. We look at angles and similar triangles. So let's get into it. The question in front of us has two circles with multiple triangles in it. The statement says, the diagram shows two circles that touch at C. A, B and C are points on the small circle with center X. C, D and E are points on the larger circle with center Y. AX, CYE and BCD are straight lines and YDE angle is X degrees. Part A says prove that triangle BCX is similar to triangle DCY. Give a reason for each statement you make. Okay, first let's look at these and study these triangles. So the line BD is a straight line and so is the line XY, and they both cross at a common point C. Therefore, this angle right here and this angle right here are exactly the same because they are vertically opposite. Okay, that's one of the reasons. The next reason can be that this angle right here is the same as this angle right here. Why? Because XB and XC both are the radius. It's the same for the larger triangle because angle DCY and angle CDY are also going to be the same. So all these four angles BCX, XBC, DCY and CDY are all the same. Well, if these four angles are the same, then of course the last statement can be that angle BXC and angle DYC is also going to be the same. So we have our three statements. Let's write them down. So first one is that angle BCX is equal to angle DCY. Why is that similar? Because they are vertically opposite angles. Okay, the next statement that we thought of was that angle XBC is actually similar to angle BCX, and angle YDC and angle wrote the angle sign twice. Angle DCY are the same. Why? Because they are an isosceles triangles. Okay, so we've covered these four angles up till now. Now we're going to write down the statement for the last angle because that's also going to be the same. So let's write that down as well. The third statement that we can make is that angle CXB, CXB and angle CYD are the same because of course this is an isosceles triangles and other four angles are exactly the same, so the third angle is also going to be the same. Okay, let's move on. The next part says find in terms of X. Part 1 says DCY. So let's remove all these scribblings first. Okay, 1 second. They've asked us to find this angle in terms of X. Now how do we do that? If we can find this angle right here, it would be exactly same as DCY. So what is this angle? According to a circular property, this whole angle, this angle is 90 degrees because CE passes through the center and it's the diameter, so this angle right here is going to be 90. So if we just talk about this angle, it is going to be 90 minus X. If this is 90 minus X, that means this is 90 minus X. So we write the statement right here. It is going to be 90 minus X. Okay, the next part says angle BXA. Which one is that? BXA. Okay, now if we have this angle, we do have this angle, this is 90 minus X. Now according to another circular property, this angle right here is twice of this angle right here. That means if you multiply BCX by 2, we would get BXA. So let's write this down first. BXA is equal to, twice of BCX. And what is BCX? BCX was 90 minus X. So the angle comes out to be 180 minus 2x. Okay, so we write that down over here, 180 minus 2x. Okay, the last part says given that BC is equal to 3.5 centimeters. Oh, one second, let's label them because there are too many dimensions mentioned over there. So, one second, yeah. So, BC is 3.5. This is 3.5. And then it says CX is 3.2. This is 3.2. Okay. And then CD is 5.6. CD, this is 5.6. We have to calculate the length of AE. How do we do that? First of all, we would need the length of AC. How do we do that? Since XC is the radius, that means if you multiply this by 2, you would get AC. Let's do that. So AC is twice of CX, and CX was 3.2. So AC becomes 6.4 centimeters. We have the diameter of the smaller circle. Let's find the diameter of the larger circle. So for the larger circle, we need this length. Now we will need to use the concept of similar triangles to find out this length. So we say that BC over CD is equal to XC over CY. So let's write that down. What did I say? I said BC over DC is equal to XC over, one second, the third one was YC, yeah, YC. So BC was 3.5, and DC was 5.6, and XC was, where did, okay, it was 3.2. So let's say that CY is X. So let's cross multiply them. X is equal to 5.6 times 3.2 divided by 3.5. One second. This comes out to be, let's do that, 5.6 times 3.2 divided by 3.5 comes out to be 5.12. Now, we have this length over here. This is 5.12, which is the radius of the larger circle. So we multiply this by 2. So if you multiply this by 2, we would get, one second, 10.24, which is CE. So this is the length of CE. So we have to find AE. What we do is we add CE and AC, which is 10.24 plus 6.4. This gives us 6.4 plus this gives us 16.64. So we write that here. I hope this question made sense. The complete working of this question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.